What if we could tell you everything? The entire history of the world. Now, what if we told you we could do it in just 2 hours? We're going to tell the whole story, from the Big Bang to the present day. How the planet prepared for the rise of man. How the Stone Age led to the steam engine. How the first seeds sprouted into cities and civilizations. Everything is connected, and the path leads to you. It took history 13.7 billion years to unfold. We'll show you everything you need to know in the next 2 hours. This is our infant universe. Everything that will ever exist, everything that will ever happen, all begins here, within this tiny bundle of energy, smaller than an atom. And right now, history as we know it is about to mysteriously begin. For reasons we may never know, our universe suddenly erupts.
In a millionth of 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 a second, it went from a size smaller than an atom to bigger than a galaxy. Whoosh!
What you're seeing is energy, and it's one key to understanding everything that will unfold in the next 2 hours. Within a fraction of a second, the Big Bang creates all the energy that will ever exist. All the energy that will power the stars, that will fuel anything that ever lives. All the energy that you will ever consume dates back to the beginning of time.
When you put gas into your car, you're tapping energy that was created during the Big Bang. You're tapping the energy of the universe itself.
We're only a few minutes into our 2-hour journey, but already 380,000 years have passed. You are about to witness the birth of your original ancestors, the first atoms. This is hydrogen. The universe will use it to make everything in the world around us.
Hydrogen is like a baseball team. You say, what player do I want to start my team with? Well, if I want to start a universe, I want to start it with hydrogen. Because from that, with a lot of heat and a lot of pressure, you can build more kinds of atoms.
The first atoms blast through the early universe. And luckily for us, they don't spread out evenly. Because in those tiny pockets with more atoms, gravity, the great sculptor of the early universe, begins to work its magic. The first galaxies are beginning to form, revealing a timeless secret of the universe. Throughout history, whenever more matter and energy can be drawn together in one place, more complex things can emerge.
We have all of these urban centers around the planet where so much creativity, so much art, so much science, so much culture came about because of all these opportunities for things to interact with each other.
Really, in a sense, where there is stuff, new stuff can develop, and where there isn't anything, nothing much can develop.
300 million years after the Big Bang, inside of forming galaxies, gravity continues to squeeze together clouds of gas and dust, causing pressure and heat to violently rise. When the temperature reaches 18 million degrees Fahrenheit, hydrogen atoms slam together, creating a new element, helium, and radiating bursts of energy. The first stars are born.
Suddenly, there were these new beacons of light shining forth, pouring energy into the universe. Let there be light.
But something is missing from this early universe. There are billions of stars, yet not a single planet. To form planets, and eventually people, to take the next leap that would make all of history possible, the universe needs more to work with than just hydrogen and helium.
The complicated elements, the heavier things that we build stuff out of, for example, iron or life built out of carbon and things like that, they're actually manufactured in stars.
We may see stars like our own sun as sources of light, but there is something bigger happening deep inside. Stars are element factories. They fuse hydrogen into helium, helium into lithium, forging 25 of the most common elements we'll need to live, including carbon, oxygen, nitrogen, and iron. So, more than 12 billion years ago, stars are already creating the element that will spur the Iron Age, allow for the building of cities, and the creation of some of mankind's most famous monuments. But a look at the Statue of Liberty reveals the next challenge awaiting the early universe. While the statue's frame is iron, her skin requires an element too heavy to be made in stars. For Lady Liberty to have material for her skin, for there to be gold for wedding rings, or uranium for nuclear reactors, some elements had to be created another way. Stars don't have enough energy to do the job, but if the element factory isn't powerful enough, how about blowing up the factory?
Just a few million years after the first stars formed, some of them exploded. Wham!
These explosions, known as supernovas, are the biggest blasts in the universe since the Big Bang, providing the extra boost of energy needed to fuse heavier elements. In the fiery blast of their own destruction, stars create uranium, gold, all the rest of the elements that will fill our world, including copper.
The periodic table of the elements is really sort of a library of matter in the universe. Those are your building blocks. Everything is coming out of that particular chemistry set. Supernovas are absolutely necessary for us to be here. You know, we have iron in our blood. We have little bits of old supernova, therefore, just floating around through us. We are all stardust.
Copper and tin, Bronze Age. Without supernovas, there's no Bronze Age. Go to any supermarket and buy a multivitamin. And go and look in the ingredients. You'll find copper, you'll find zinc, you'll find selenium, you'll find all sorts of elements that can only be made in a supernova.
The elements made by stars will become the seeds of life on Earth and the drivers of human history. But the journey has just begun. Before there can be life, the universe has to build us a suitable home. To build a proper house, you have to assemble the right materials all in one place.
Now, when planets form, It's the same thing. It's the materials that you have at hand that's going to dictate the kind of house that your planet's going to be.
To get enough of the right material in the right place, all at once, takes a very long time. Over the next 8 billion years, more than half of history as we know it, the element factories continue their work. Stars explode and are reborn. Each generation with more heavy elements than the last. Until 4.6 billion years ago. Finally, there are enough materials gathered for the next step on the path to us. A new star is born. This is our sun. It's so massive that it's gathered up 99.9% of the gas and dust in the solar system. But there's still just enough left behind for gravity to build some other things. Like planets. The third one out from this star will be our home. By the time Earth emerges, just over 4.5 billion years ago, 2/3 of the history of the universe has already passed. The first sunrises sweep across a foreboding alien planet. A world spinning so rapidly that a day lasts only 6 hours.
When you go back to the early Earth, right after the planet formed, you really have to think of the Earth as another planet. The sun would have looked out over a hellacious scene of just molten lava. In places, you would see rafts of black volcanic rock.
Within the liquefied rock, the elements are all in a jumble. Something has to bring order out of this chaos. And once again, that something is gravity. Lighter material drifts toward the surface and forms a solid crust, while heavier material sinks toward the center, forming a molten iron-nickel core. This churning liquid metal creates a magnetic field that reaches out into space. Like a force field, it will protect our future home from the sun's deadly charged particles. Soon, this magnetic field will allow for life to grow, and later, guide the explorers who will connect two halves of the world. But for all this to unfold, the Earth will need a critical partner. Four and a half billion years ago, an object the size of Mars smashes into the planet at 25,000 miles per hour. Earth swallows up much of the impactor. But a spray of molten debris is whipped off into space. Within as little as a year, gravity gathers this debris into a secondary sphere in orbit around the Earth, where it has been ever since.
The formation of the moon was an incredibly important event in Earth's history.
And in fact, its creation over 4 billion years ago is really important to the Earth's climate today.
The moon keeps Earth steady. Its gravitational pull prevents the planet from wobbling, saving us from wild climate swings. And the collision that formed the moon leaves Earth tilted on its axis, giving the planet a key ingredient to life: seasons.
Having seasons is very, very important for the evolution of life on the Earth. And having some stability in the tilt of those axes, that's very, very important also for maintaining life on the Earth.
The moon's gravity also begins to slow Earth's rotation, which will eventually lengthen our days from 6 hours to 24. 4.4 billion years ago. It's too hot on Earth for liquid water to exist, but there's water vapor, steam in the atmosphere. The trick is how to get it out of the sky onto any world where you hope to have life. A little rain must fall. For millions of years, as the planet cools, rain pours down, forming puddles, lakes, and eventually our oceans. By 3.8 billion years ago, our planet has a moon and permanent oceans. But it hardly resembles the place we now call home. To become the stage for all of human history, Earth needs an oxygen-rich atmosphere, fertile continents for people to discover and develop. Who will create our modern world? There's 1 trillion of them crawling on your skin right now. We're telling the history of the world in 2 hours, from the Big Bang to the present day. And our modern world holds important clues to the story. In fact, structures like this hide a mysterious link to the first life on Earth. $3.8 billion years ago, beneath the surface of our primeval oceans, a revolution is taking place. 6 simple elements, including hydrogen from the Big Bang, and oxygen, carbon, and nitrogen created by stars, have combined to form the key substances that will make up all life, including us. The most spectacular is DNA. Within its spirals hide the secret codes of life. 700,000 years after the planet first formed, life on Earth begins. We stand not on the shoulders of giants, but of tiny organisms, bacteria.
We're very egocentric. We think that we animals run the world, but in fact, we are very late entrants. It was an empire of bacteria long before animals. Animals come along, and we like to think that we wiped out that empire. Well, we would be dead if we wiped out that empire. I have within me an entire zoo of bacteria.
In fact, each one of us has more bacteria living in our bodies than there are people on the planet. For billions of years, microbes like these will have Earth to themselves. Like our infant universe, the first life is small, simple, and full of possibilities. The secret of how it explodes into all the incredible forms we see today, including us, goes back to the beginning of time. As we've seen, all the energy that will ever exist was created in the Big Bang. All creatures need to grab their share of this energy to survive. The more we harness, the more efficiently we use it, the more complex we can become. And almost all of our share of the Big Bang's energy is beamed to us by the sun. 2.5 billion years ago, some very special bacteria figure out how to consume the sun's energy to live. In doing this, they also create the most important waste product in the history of the world: oxygen. Soon, oxygen will remake our world. But first, it has another important job to do. Earth's ancient seas are full of iron particles, and everyone knows what happens when oxygen meets iron.
Here I'm a little bacterium. I've produced this oxygen molecule, and here's a big piece of iron clump. I rust it.
This rusted iron collects on the seafloor. Billions of years later, these huge deposits will be raised up to become major sources of the world's iron and steel.
It was these iron deposits that later on drove the Industrial Revolution.
In this way, the Brooklyn Bridge and the other early landmarks of the Industrial Age are a direct link to some of the first life forms on Earth. Once there's no more iron left in the sea to rust, these ancient bacteria have a mission to complete. They create so much oxygen that it fills the oceans and escapes into the atmosphere.
And from then on, we have a very different planet from all the other planets in the solar system.
Now, life takes a giant leap. For the first time, some bacteria learn to live on oxygen. Every human breath is a ritual, 2.5 billion years old.
Life tends to stick with what works, even over the course of billions of years.
Oxygen is a game changer. By taming its power, life has found a better way to energize itself, 20 times more efficient than anything used on Earth before. What life does with all this new energy will be the story that leads to us. Over the next 2 billion years, life becomes more complex. Skies become blue, and so do the oceans that reflect them. Large, solid continents appear. Earth is beginning to look more like the place we now call home. $550 million years ago, as the planet celebrates its 4 billionth birthday, oxygen levels in the atmosphere have risen from next to nothing to as much as 13%. Take a deep breath, because life on Earth is about to go wild. This is the Cambrian explosion, biology's version of the Big Bang.
Right after you have abundant oxygen, you get size and complexity, and oxygen lets you do that.
It's in this breathtaking span of roughly 30 million years that most of the major animal groups evolve. By 500 million years ago, the first bony fish have evolved in the seas. These fish are our direct ancestors. Though they look nothing like us, they evolved the body parts that will make our own bodies possible, including a spine and a mouth with jaws and teeth.
We owe a great deal to our fish ancestors. In fact, all vertebrates today really represent modifications of the original fish body plan.
For the first 4 billion years of Earth's history, plants and animals have stuck to the seas. But that all begins to change. With oxygen comes an ozone layer, protecting us from dangerous radiation. Plants make the move first. Around 400 million years ago, animals are ready to take the leap. Among the first ashore are the amphibians, whose descendants will include us.
The most amazing thing about animal evolution ever for me personally is that moment that first amphibian walks out of the primeval ocean onto land and takes a big gulp of air. Kind of like great-great-great-great-great-great-grandpa coming out of the ocean and seeing this fantastic world. And it's like, hey, I can live here. Look at those trees, look at those bugs. There's food here, I can do this.
Eventually, humans will conquer every imaginable terrain. But before we can do that, our ancestors must first cut their final tie to the water. Mating season. Like modern frogs, they have jelly-like eggs that would dry out on land. But some amphibians eventually solve the problem. They evolve a new form of egg, with a shell that keeps the moisture in. This allows us to carry the ocean with us, onto land, and signals the evolution of amphibians into reptiles.
You could be 300, 400, 500, 1,000 miles away from water and still have the water in that egg in order to birth. That is the key. It cuts that final tie to the ocean. That way we could colonize the rest of the land.
$300 million years ago, life flourishes in massive tropical swamps where planet Earth is cooking up a surprise. As plants die here, they are buried, compacted, and cooked. Energy created in the Big Bang and radiated by the sun to plants on Earth is now locked away underground as coal, a gift to be opened by human beings millions of years in the future. $250 million years ago, an apocalypse unfolds. The biggest spike in volcanic activity since the early days of the planet. The atmosphere is choked with carbon dioxide, and the diversity of animal life spawned in the Cambrian explosion is stopped dead in its tracks. More than 70% of all species on Earth go extinct in the worst mass die-off in history, the Permian extinction. Extinction is a recurring character in the story of planet Earth. 5 times in the last 500 million years, some cataclysm wiped out the dominant species. It's a reshuffling of the deck that allows new creatures to take hold. New creatures like the dinosaurs. Dinosaurs will reign for the next 160 million years. During that time, the first hardwood forests appear. And after more than 4 billion years, the moon's gravity finally settles Earth into a 24-hour day. At the start of the dinosaur era, the continents are clustered together into a single landmass we call Pangaea. But now, they start to break apart. Africa separates from South America. The vast Atlantic Ocean opens up, creating what will become one of the defining barriers of human history, the gulf between the old and new worlds. The undisputed stars of the dinosaur era are animals like Triceratops and T-Rex. But there are some important creatures scurrying around their feet.
If we were to trace our lineage back far enough, we would come to really small shrew-like mammals surrounded by these titans of reptile life. During that time, mammals, we were living on the fringes. We were maybe stealing dinosaur eggs, maybe just eking out an existence. So the dinosaurs kind of held us back.
The biggest headline of the history of dinosaurs, which is 160 million years, is that we lost. Mammals lost. We couldn't get much bigger than a small cat. For 160 million years, all the medium-sized, medium-big, big, gigantic, and stupendous animals were dinosaurs. For that whole time. They beat us fair and square.
But the deck is about to be reshuffled. "65 million years ago, a 6-mile-wide object, likely an asteroid, slams into the Earth. A dust cloud blocks out the sun. Temperatures plummet. Every creature on land weighing over 50 pounds goes extinct. The reign of the dinosaurs is over.
The greatest gift that the dinosaurs ever gave us was dying. When they went extinct, it gave the mammals time to rise.
It doesn't take long after the disappearance of the dinosaurs for the first true primates to appear. Like their later versions, including us, these mammals have evolved forward-facing eyes, allowing for accurate depth perception and flexible hands with 5 digits.
They have 5 fingers, just like us, which means we can grasp things. If you think about other animals that don't have digits organized the way ours are, their ability to hold things, to manipulate objects, is much more limited.
50 million years ago, our primate ancestors are evolving on a planet that is warming. It's so hot, there are jungles at the poles. As the continents drift, the Americas and Africa have almost fully taken shape. But in northern Africa, modern-day Egypt is submerged beneath an ancient sea. On the floor of that sea live small-shelled creatures called nummulites. Their shells, made of calcium and carbon, pile up on the sea bottom over millions of years, where they form into limestone. Limestone that will be used to build the Great Pyramids. If you look closely at the pyramids today, you can still see evidence that these 4,000-year-old monuments are, in fact, made of 50-million-year-old seashells. By 10 million years ago, Earth is morphing into a world most of us would recognize. The Colorado River is carving out the Grand Canyon. Mountain ranges like the Himalayas have arisen. They're so tall, they disrupt weather patterns, setting the stage for a colder planet. The Isthmus of Panama emerges to connect North and South America, cleaving the connection between the Atlantic and the Pacific, disrupting ocean currents and tipping the world even more towards an ice age. With the planet getting colder, our primate ancestors hang on in the tropics. But a new creature is coming in that threatens to destroy them. "7 million years ago, our primate ancestors lived safely in the trees. But their neighborhood is about to be invaded. This newcomer will have as profound an effect on human history as any other living thing on Earth. It seems almost impossible to believe, but one of the most important things that will lead to the emergence of us is the emergence of grass."
The grasslands appear almost simultaneously around the world. We get the African savannas. We get the Eurasian steppelands. We get the North American prairies. We get the great grasslands of Argentina, appearing simultaneously around the world.
In eastern Africa, Grasslands invade the traditional woodland habitat of our ape ancestors. With fewer trees and greater gaps between them, our ancestors have to adapt.
Apes would notice that there's more and more apes in the same tree and less food, increasing incentives for apes to go from one patch of food to a different one separated by grasslands. Now, one way to do it is to run like hell. The other way to do it is to extend one's food sources into the grasslands and seek out the foods that are available there.
And so, some apes make the move down into this stark new habitat. It's a landscape better suited to primates that can walk on two legs, keeping their heads up above the tall grasses to watch for predators. Standing on 2 feet is a revolutionary advance because it frees up our hands. Hands we will need to shape human history. $2.6 million years ago, early proto-humans, or hominids, walk an Earth whose rocks are loaded with the element silicon. Created in the cores of stars billions of years before, silicon is the second most abundant element in Earth's crust. One of its chemical quirks is the ability to bond with oxygen to form crystals that combine into solid rocks. Rocks that can be chipped and shaped without shattering.
Hominids started doing this 2.6 million years ago, breaking cryptocrystalline silicates to make sharp edges, and people use them for millions, literally 2.6 million years.
Simply having a modified stone with a sharp edge on it, now suddenly you have a hammer. You have a crude cutting edge. A simple modified stone means a human can suddenly do 1,000 more things than we could do previously. That little extra bit of technology enabled our ancestors to persist and eventually turn into us.
Silicon launches the first technological revolution, the Stone Age. Millions of years after it powers our first handheld devices, another chemical quirk of silicon will make it the height of technology once again. The next leap towards becoming truly human relies on a little-known secret of our home planet. In the known universe, it turns out Earth may have a rare and special power.
Of all the planets and moons in the solar system, we think that Earth is unique in the ability to sustain fire.
Other planets and moons have lightning and lava. But only on Earth do we have the two critical things we need for fire to burn. A vast fuel supply in the form of plants and trees, and an atmosphere full of oxygen to fan the flames.
If fire wasn't a possibility, you'd have nothing like us running around. Homo sapiens, they made a world with fire.
Our ancestors have fire firmly under control by 800,000 years ago. It's a skill that connects us back to the very beginning. Remember that all energy was created in the Big Bang, and all life is in a competition for our share of this energy. Using fire to cook is like having an external stomach to break down foods, releasing more calories, giving us more energy, which in turn allows us to support bigger brains. Fire is also the ultimate gateway technology. We will soon use it to turn clay into pottery, metal into weapons, water into steam power.
If you don't have fire, you can't have the internal combustion engine. No fire, no metal. No fire, no rubber. It's a technology that opens a world of possibilities for creatures that know how to use it.
"200,000 years ago, the modern human has fully taken shape. The larynx, or voice box, which is high up in the throat in our ancestors, descends. More complex sounds are now possible. We begin to speak. For the first time, information can be shared between individuals and across generations. Humans have gained a critical advantage over every other creature on Earth.
You can tell my grandfather said that when the elephants didn't show up, we go off and hunted zebras. You know, my aunt told me that her cousin found this water hole on the other side of that river.
And we can all benefit and we can all understand what they mean when they're describing what they found out on that landscape.
Language changes humans from being like standalone computers to being networked computers, where you can share information. You know, one doesn't need to depend on one's own personal experience. One can borrow the personal experience of anyone with whom one can communicate. That's a powerful advantage. No other creature has that.
As a species, humans become exponentially smarter. The global game board has been set, and we are now ready to play. 100,000 years ago, man can move. We have agile hands and primitive tools. We can communicate and control fire. We are finally ready to expand out of our African home on a path millions of years in the making. Shifting continents have linked Africa and Eurasia into the largest contiguous landmass on Earth, Afro-Eurasia. 33 million square miles, more than twice the surface area of our entire moon. For early humans, this means more than half the land on Earth can be reached on foot.
Human dispersal was a crucial game changer. We are one of the few primates that live on more than one continent simultaneously. So what that means is that we're better insulated from the kinds of things that cause big mammals to become extinct than other primates are. It's extinction insurance. Dispersal is extinction insurance.
But just as the world begins to open itself up to man, the planet turns on us. An ice age begins. Now the planet will test us like never before. By 50,000 years ago, glaciers begin to advance down from the North Pole. At the same time, humans continue their conquest of the globe, arriving in China and Australia. By 30,000 years ago, Homo sapiens reach Europe for the first time. By 20,000 years ago, with the ice nearing its most extreme, the march of man reaches the frigid tundra of northeast Siberia. Despite the trials of the Ice Age, man endures and develops the last skills we will need to be truly human. The clues lie in these symbols. We have taken an intellectual leap to think beyond the here and now, beyond what is simply needed to survive.
We can only start saying we have an organism that is human, that is the same as us, when we start seeing evidence of symbolic thought. It's when we start seeing a picture of a cow that everybody will recognize as the picture of a cow. Because only when we start seeing all of those things can we say that is a human. People or creatures that think like us, that see the world in the same way as us.
And from that moment on, human history was marked to be radically different to any other species on this planet.
Now, with huge amounts of the planet's water locked up in ice, sea levels plummet by 300 to 400 feet. The last great barrier to the spread of man is erased. We come across the Bering Land Bridge from Siberia to North America. We are telling the history of the world in 2 hours, and in just 1 hour, more than 13 billion years have already passed. These years of preparation have allowed man to finally emerge and spread out across the planet. And human history as we know it can truly begin. Our history of the world began with the beginning of time, the Big Bang. It has taken us on a journey of nearly 14 billion years. Now, as humans take center stage, it's important to remember just how small a slice of history we actually occupy. To make things simple, imagine compressing 14 billion years of history down to just 14 years.
On this scale, the Earth would have existed only for the past 5 years. So that's about 1/3 of the history of the universe. Large, complex creatures would have developed 7 months ago. On this scale, dinosaurs went extinct only about 3 weeks ago. The entire recorded history of humans would span only the last 3 minutes. Modern industrial societies, the Industrial Revolution effectively, 6 seconds ago. What this shows me is that we humans have been around for only a very brief instant in the recorded history of the universe.
Mankind has waited billions of years for our brief instant to shine. As the stars and our evolving planet carried out the slow work of organizing the elements in a way that would make human history possible. It's 10,000 BC, less than 100,000 years after expanding out of Africa. Man has reached South America. Humans have met the adversity of the Ice Age head-on, and rather than die off, we have adapted, become even more intelligent. And now we have colonized the entire globe. From coast to mountaintop. From tundra to desert. Humans are there.
Our closest living ancestors, chimpanzees, live in the tropics. They only live in the tropics. Humans have managed to colonize the entire globe.
Ice Age land bridges allowed man to spread around the world. But now the ice begins to melt. And sea levels rise again. Humans are trapped and separated in 2 vast and unconnected hemispheres. Each pocket of humanity left to make the best of what it has been given. As the glaciers recede, they carve out lakes, rivers, and bays. The map as we know it emerges. In Africa, increased rainfall causes Lake Victoria and Lake Albert to overflow and form Egypt's Nile River. In Eurasia, other rivers emerge. The Tigris and Euphrates in Mesopotamia, modern-day Iraq. The Indus in modern-day Pakistan, and China's Yellow and Yangtze.
These river valleys become critically important for how human history will now be played out following the retreat of these ice sheets.
These are the river valleys whose waters and fertile soils will allow the first seeds of civilization to be planted. With temperatures warming after the Ice Age, plants and animals are more plentiful, and man can finally choose to stop moving. Permanent settlements begin. Populations grow, With more mouths to feed, our ancestors have to get clever.
They had to find a way to increase the amount of food they could get from the surroundings.
Now, one discovery forever changes the planet and the path of mankind. We learn to plant seeds. And the seeds we sow come from the same plants that millions of years earlier spurred our evolution from ape to man. The unheralded hero of human history, grass.
A grass seed is tiny, right? It's no food. I can hunt a bison or I can take grass. I'm gonna hunt a bison, right? Ironically, grass seeds become the most important food crops in the world, but they're the things that are ignored by hunter-gatherers for thousands and thousands of years. People don't start using them until they absolutely have to use them.
Some of the species of grass that we are most familiar with includes sugarcane. It includes wheat and rye and barley. All of the cereal crops are types of grass. So it's not just that beautiful green lawn that we measure our middle-class success from. It's also the staple crop upon which civilization depends. It is the majority of our calorie intake.
Once again, it all goes back to the Big Bang. Central to the story of all life is our competition for that energy created at the beginning of time. Just as oxygen gave us an edge, just as fire allowed us to consume more calories. Switching to farming is an energy revolution. A hunter-gatherer needs 10 square miles of territory to provide himself with enough sustenance, enough energy in the form of plants and meat to survive. A farmer can harvest the sun's energy so efficiently, he can fulfill his needs using only 1/10 of a square mile of land. In the warming after the last ice age, farming begins to take hold in a half-dozen places around the globe. But by the fortunes of geography, no place in the ancient world has a better concentration of plants and animals that can be domesticated than the Middle East's Fertile Crescent.
In the Middle East, we have this remarkable convergence of species that seem to have been susceptible to domestication, both plants and animals. In terms of animals, we're talking about cattle, pigs, sheep, and goats. In terms of plants, 2 varieties of wheat, rye, barley, lentils, figs, all in this very small part of the world.
Unlike the Fertile Crescent and the rest of Afro-Eurasia, places like sub-Saharan Africa and the Americas have very few wild species that can be easily domesticated. It's a critical difference. People blessed with the right mix of plants and animals will become more powerful and get a massive head start on the road to the modern world. One animal that gives any human who can tame it an almost unbeatable edge is the horse. It's a little-known fact that although horses first evolved in the Americas, they died out there along with many other large mammals around 10,000 BC.
There were at least 3 species of Ice Age horses in North America, maybe more. Some as small as ponies, some as big as Clydesdales. And they had evolved in North America for 40 million years. They're part of the whole history, and then they're gone. They're gone.
These powerful potential allies disappear before they can be used by the first North Americans.
Fortunately, before that happened, large numbers of horses escaped back across the Bering Strait land bridge and spread out across the great grasslands, the steppe of Central Eurasia.
A narrow escape that had a profound effect on human history. Around 4000 BC, nomadic people in Central Asia learned to tame them for the first time. Domesticated horses will be harnessed across Eurasia, advancing everything from work to warfare. Perhaps no other animal has had a bigger influence on the course of human history. And the circle wouldn't be complete for another 5,000 years when Christopher Columbus would bring horses with him on his second voyage to the Americas. His horses would be the first to set hooves in the Americas since the Great Die-Off over 10,000 years earlier. "6,000 years ago, domestication of animals and plants sets the stage for the next phase of human history. Like clouds of interstellar dust gathering in material to form stars, a type of gravity is at work as places like Sumeria, located in part of the Fertile Crescent known as Mesopotamia, draw in people, support large populations, and spin up into centers of power and innovation. By 3000 BC, some of these Sumerian settlements can truly be called our first cities. One of them, Uruk, has around 50,000 people living in less than 1 square mile. A population density that rivals modern-day New York City. Humans have become so efficient at deriving energy from domesticated food that this land area, which would have supported only a single hunter-gatherer, now can support thousands. But a change in diet also triggers a new dependence.
Once you move to agriculture, you are depending for 80–90% of your calories on perhaps 1 or 2 species. In the case of the Middle East, wheat and barley. In the case of wheat and barley, they both ripen at about the same time. Humans have to gather the seeds at the same time. So now we have our food for the year that has arrived in one hit. It's like getting your salary paid once a year. You need to record it, you need to plan, because if inevitably your crop fails, you have famine, and you're not gonna have another go for another 12 months.
In these first cities, crops are king. To keep track of them, our ancestors developed the first writing. To protect them, the first armies. And to administer them, the beginnings of politics.
When you have hundreds or thousands of people who are living together, there's simply too many people to sort of run around and create a census. It creates a need for government. It creates a need for some form of social and political hierarchy.
Planting seeds has set man on a new path. Settlements have grown into cities. But to take the next epic step from city to civilization, we'll need the help of a very surprising creature. "5,000 years ago, after wandering the Earth for more than 100,000 years, mankind has begun to settle down. We cluster near rivers, along the Tigris and Euphrates, the Nile, the Indus, the Yellow and Yangtze. Civilizations are about to take off. But first, they must all master one thing: trade. The more they exchange goods and learn from other lands, the faster they grow.
It seems that long-distance trade and communication is a necessary precursor to allow urban civilization as we know it.
And surprisingly, the first civilizations arise on the back of a creature with a lowly reputation in the modern world: the donkey. The donkey caravan is the interstate highway and high-speed internet of its day. Their routes will lay the groundwork for the modern world. Moving not only goods like timber and bronze, but ideas and stories. The civilizations they connect will be some of the first described in the Bible. The caravan routes converge at the Persian Gulf, where they link up with ships that carry goods to India.
It essentially brought these civilizations together into great cultural and material exchange, and really was the beginning of the trend towards globalization.
It is a key to understanding how our world works to this day. Just like the first civilizations, we trade and form networks. These networks form hubs. And throughout history, being at that hub has meant one thing.
The amount of ideas, the amount of cargo that passes through a region seems to have a direct correlation to how powerful and important they are.
By 2000 BC, humans have gone from humble huts to massive monuments. In Africa, great pyramids arise on the banks of the Nile. The first stages of Stonehenge rise up in ancient Britain. And back in Samaria, artificial temple mounds called ziggurats climb ever higher toward the heavens. To cement these massive structures together, the builders of Samaria turned to a substance that oozes from seepages along the Euphrates River. It's called bitumen. Used as asphalt in the modern world, it is the first petroleum product to be exploited by mankind. While bitumen is highly prized, the lighter, thinner substance oozing from the ground along with it is considered a nuisance by the ancients because it catches fire so easily. The ancients call it naphtha. We call it gasoline. And it's one of the first indications of the vast oil fields that will one day turn the cradle of civilization into a center of wealth and warfare. The legacy of these first civilizations can be seen in surprising ways. The Sumerian counting system was based on the number 12 rather than 10, which is why we divide our days into two 12-hour blocks, our hours into 60 minutes, and our minutes into 60 seconds. The Sumerians also likely invented the wheel, which eventually leads to another innovation that will change the course of man: the chariot.
Thus bringing together the Sumerian invention of the wheel, right, with the domestication of the horse that had occurred amongst these nomadic peoples into this really formidable piece of military technology.
Around 1200 BC, a chariot-driven clash of civilizations cuts off trade routes for copper and tin, the metals we need to make bronze tools and weapons. But luckily, the stars have made us an alternative: iron. Now, metalsmiths make a crucial discovery. By working at higher temperatures, they can release the power of this ancient metal. Easier to sharpen and 700 times more common on Earth than copper. It is a game changer. Humanity enters the Iron Age. As we reach the first millennium BC, history has taken us on a wild ride. From the initial blast of the Big Bang, to the formation of Earth and its first creatures, and the rise of man. We've seen the Ice Age create bridges to spread mankind around the world, then strand us on different continents, leaving us to survive on what we have at hand. So by 1000 BC, the world remains a divided place. The trade network that connects much of Eurasia and North Africa doesn't yet penetrate the planet's driest deserts or cross the vastest oceans. Cut off by geography are people in places like sub-Saharan Africa and the Americas. With few easy to domesticate plants and animals of their own, they remain tied to more ancient ways of life. In 600 BC, the cavalry have arrived. Humans ride into battle on horseback for the first time. We've seen that just taming a horse gives man a massive advantage. Now, pairing him with iron weapons makes him nearly unstoppable.
These advances in technology, they don't just make a fighting ability possible, they make empires possible.
And that is the story of the next several millennia. With new technology and improved logistics, empires spread, uniting massive land areas under a central control. As empires grow, so do new beliefs.
One interesting phenomenon we see with the rise of these empires is this idea of monotheism, this idea of a universal God that develops over time, and it's just a phenomenon.
Judaism emerges, from which we eventually get Christianity and Islam. Buddhism and Hinduism also arise. The 5 major religions today are all rooted in this remarkable era. Although empires spread, some great powers remain isolated. The rise of the Himalayas 50 million years earlier has left China cut off from trading with the rest of the world. But that is about to change. Around 100 BC, a Chinese emperor sends an envoy to the west in search of alliances. The routes he travels will become the Silk Roads, a massive trade network that connects China across Central Asia to the Roman Empire. China has joined the world.
As far as we know, no Chinese trader ever met a Roman, no Roman ever met a Chinese trader, at least during this first period of the Silk Roads. But this vast trade then began to explode. Between about 100 BC and about 200 AD, we have 3 centuries of trade and cultural exchange on a level that has not been seen before in human history.
But this new human network also unleashes hidden dangers. By the beginning of the Common Era, great empires have risen and a massive trading network connects most of Europe and Asia. But the trade routes also carry an invisible threat. Disease. Massive epidemics that some blame for taking down both the Roman Empire and China's Han Dynasty. But these networks also lead to the spread of religion. In 312 AD, the Roman Emperor Constantine converts to Christianity, paving the way for it to become the dominant religion of Europe and the West. Three centuries later, Islam also emerges. A religion that will, for a time, unify a territory 2.5 times larger than Rome ever was. Arab trade will drive innovation for the next 1,000 years and expand the global network to places it has never gone before.
The Arabs are sitting in the middle of Afro-Eurasia. There are Arab traders who are sailing off to China. There are Arab traders who are traveling all the way to the Atlantic Ocean. So they are sitting in the middle of the hub.
One secret to Arab trade: the camel. A creature whose ancestor, like the horse, escaped across the Bering Land Bridge out of North America. A caravan of 6 camels can lug as much as 2 tons of cargo as far as 60 miles a day, twice the load of a donkey caravan in half the time. For the first time, camel caravans open up reliable trade routes across the formidable Sahara Desert, leading to the formation of the first states in West Africa. Arabic trade expands, moving salt from the Sahara to Rome, rice from Eastern Asia to India, the secrets of making paper out of China into Europe, and countless other inventions and ideas around the world.
Where does our word for lemon come from? Where does our word for coffee come from? They're all Arabic, because the Arabs brought a huge number of food crops into Europe. Oranges, citrus crops, they come from South China. Yet they don't make it to the West until the Great Age of the Arabs.
In Islamic North Africa, one Italian merchant named Leonardo Fibonacci becomes well-schooled in the ways of Arab traders. He picks up on a simple but ingenious counting system that originated in India but is used extensively in the Arab world. His writings will spread this knowledge to Europe and around the globe. With everyone counting the same way, business and trade will explode. And because of Fibonacci, people today still almost universally use the numbers known as Arabic numerals. But there is another idea Arab traders will spread, something even more influential. It originates in China around 800 AD. A Chinese alchemist in search of an elixir for long life instead stumbles upon chemistry that can bring sudden death. He combines carbon and sulfur with saltpeter, a compound made of potassium, nitrogen, and oxygen. Forged in the stars, these elements now come together to make gunpowder. The recipe for gunpowder eventually moves west across the Silk Roads to the Islamic world, where Muslim warriors use it to fire cannonballs at Christian crusaders. Europeans pick up on the idea, embracing and perfecting gunpowder weapons. In 1492 AD. There are roughly 400 million people in the world, but it is still divided in two. In the Americas, the civilizations of the Aztecs, Mayans, and Incas have all arisen. While halfway around the world, in the aftermath of the fall of Rome, Europe has cracked like an egg into individual states. For Italian-born Christopher Columbus, this means he can appeal for funding from a succession of European rulers, until he finally convinces the King and Queen of Spain to back his expeditions. It has taken all of Earth's history to make Columbus's journey possible. For tacking into the wind, he uses triangular sails, a technology copied from the Arabs. To guide him, the compass, an invention from China. And guiding the needle, a magnetic field formed with the core of the planet itself. Although Columbus is looking for a new way to sail to India, what he does instead is finally and forever connect the two halves of the world. The voyage is not just significant in American history. As you'll see, it's a pivotal event in all of human history. Nothing will ever be the same. The end of the Ice Age marooned large pockets of humanity on separate sides of the globe for over 15,000 years. Now, that's all about to change.
The voyage of Christopher Columbus in 1492 is taught as one of the most significant events in American history. In fact, it's one of the most significant events in all of human history. Prior to that voyage, the great world zones had existed largely in isolation. By crossing the Atlantic, Columbus opens up the vast American world zone, these two enormous continents of North and South America, with the millions of people that are living there, the resources that are available. And for the first time, people living in Eurasia become aware of this other part of the world. Until the voyage of Columbus, these people may as well have been living on different planets, so isolated were they.
A trade network that started with the first civilizations, connected Europe, Asia, and Africa, now reaches across the Atlantic. In this vast new global network, new hubs will form. And once again, power will shift.
For most of the last 2,000 years, Europe hasn't been that important. Then we get the age of Columbus, and what do you know? This is exactly the time where we see the rise of the West. This is when the West starts taking over, when it gets itself smack bang in the middle of the biggest exchange network the world has ever seen.
Now, foods that had been isolated on disconnected continents begin to move around the world. Maize from the Americas shows up in Egypt and China. Potatoes from the Andes prove perfectly suited to the soils of Ireland and Russia. The old Fertile Crescent grains, like wheat, begin to feed the Americas. New foods mean more calories, more energy. Within 3 centuries of Columbus's voyage, the population of the world will more than double to 900 million. But the unequal hands dealt to the 2 hemispheres now play out in a deadly climax. European conquistadors, inheritors of the agriculture and animals of the Fertile Crescent, and the trade spread along the vast networks of the Old World, come bearing guns, riding horses, and carrying infectious diseases. The result, slaughter. In the years following Columbus's first voyage, 95% of the native population in the Americas will die from European guns and germs. Once the hemispheres are connected, nothing can ever be the same. Take the incredible story of sugar. Chemically, it's the only source of fuel for our brains, a substance we are programmed to crave. Raw sugar comes mostly from sugar cane. Once again, a grass will play a central role in the story of mankind. First cultivated more than 6,000 years ago in Asia, Europeans discovered sugar in the Middle East during the Crusades and carried it home. Europe was hooked. But there's virtually nowhere in Europe where sugar can grow.
Then we have Christopher Columbus and the discovery of the New World. And the Spanish conquistadors, yes, they initially are very interested in the gold and the silver, but really, they just want to make it rich. They don't care how they're going to make it rich. And once the gold and the silver has been looted, the next step is to open sugar plantations. The Spanish themselves don't want to work in the sugar plantations. They start looking around for a new labor force. And over on the other side of the Atlantic, there is a place where they can buy slaves. And if we look at the history of slavery, the #1 destination of slaves from Africa are sugar plantations. So the history of sugar shapes the development of history through the Middle East, through the Crusades, through the conquest of Mesoamerica, and even the history of slavery from Africa to the Americas.
In the year 1700, mankind has hit a wall. Most humans continue to live simple lives, more like our ancient ancestors than our own.
When you think back to the world in 1700, most people were farmers, most people practiced small-scale subsistence agriculture, most manufacturing was done in workshops.
In 1700, it takes over a year for cargo and information to circle the planet. longer than it would take us today to get to Mars. What's holding us back is how we power our lives. In Egypt of 2000 BC, 90% of all work was done by human muscle, with animals kicking in the rest. By 1700 in Europe, the majority of work, 70%, is still driven by human muscle. Muscle power alone can't clear the path to the modern age. But there's a breakthrough hidden deep within the Earth. As our history of the world in 2 hours races towards a close, mankind has hit a wall. Human progress is stalled by the limits of our muscle. To break through, we'll need a new way to power our lives and the entire history of the world. Remember that billions of years ago, iron from exploding stars was gathered up into planet Earth during its formation. Thousands of years ago, man started using this iron for tools and weapons. To keep our forges burning, we began cutting down our forests. Now, 300 years ago in Britain, iron is in high demand, and the trees are running out. The British need a new source of fuel, and thanks to the decayed remains of ancient ferns, they have one. Coal. But coal itself won't power mankind into the modern world. There's one more fateful twist in the story. As the quest for coal takes miners ever deeper into the ground, water begins flooding the tunnels. To pump out the water, a new invention is needed. In 1712, Thomas Newcomen produces a pump powered by burning coal and driven by steam. Newcomen's machine is the first practical steam engine. It is this combination, energy and engine, fuel and machine, that will free man from the limits of his own muscle and change the world. The Industrial Revolution begins. Along with political revolutions in America and later France, this technological revolution forever transforms the landscape of the world.
And before long, the Atlantic world has become the new economic, therefore cultural, therefore political, therefore military leader, and will utterly dominate global geopolitics from that moment to this.
Trains thunder across the countryside. By the 1870s, the internal combustion engine has arrived, and the Germans invent its killer app, the automobile. Oil, the substance which the ancients considered too flammable to be of any use, becomes the most important commodity on the planet, fueling even more innovation. The telegraph and telephone move messages at lightning speed. With electricity, mankind reclaims the night from darkness. The hub of power has shifted. In 1800, Europeans and their descendants controlled 35% of the land on Earth. By 1900, they control 85%. By the 20th century, fossil fuels and the internal combustion engine have amplified everything, including warfare.
That technology meant that military power and military conquest was something that could be international in a way that it had never been before.
In the 20th century, almost 3 times as many people are killed as a result of war as in the previous 2,000 years of human history combined.
The application of the industrial skills, the industrial technologies of the 18th century reached their culmination, I think, with these extraordinary events. And it's all being driven again by the micro-fossilized bodies of organic entities that disappeared into ancient swamps millions and millions of years ago.
The Industrial Revolution also allows the human population to explode. It has taken 200,000 years of human history, from the dawn of man to the year 1900, for the population to reach 1.6 billion. Now, within the 100 years of the 20th century, it nearly quadruples to more than 6 billion.
The 20th century is the most extraordinary moment in human history. Never before have we seen change on such a scale.
Today, humans number close to 7 billion. We are the dominant players on the planet. We have learned to harness 50,000 times more energy than our ancestors just 10,000 years ago. This energy drives our fast-paced lives and a literal World Wide Web, a network that, as we have seen, has been in the making for as long as humans have walked the Earth. Our 2-hour story is coming to an end. A story that really began 14 billion years ago with a tiny universe where everything was all in one place. Then the Big Bang. All the energy that has ever existed created in an instant. Gravity sculpted our universe. For billions of years, stars and supernovas created all the elements we would eventually need. Then an extreme Earth took shape and settled into just the right conditions to support life. As the planet evolved, life competed for energy and grew more and more complex. Eventually, the conditions were right for our species to rise. We mastered stone and fire. When the Ice Age came, we spread around the planet. And when the ice melted, we were stranded on different continents. We learned to bend plants and animals to our will. We built cities, then civilizations. We created a vast network that linked empires, joined continents, then crossed oceans. Just when it seemed we had reached our human limit, we found the energy and technology to carry us into the future. On Earth, the seeds of the past have bloomed into a present filled with energy and creativity. The stories of billions of lives have played out against the backdrop of a universe almost too vast to comprehend. In everything that we do, in all that we are, we remain living monuments to the past as we continue to make history every day.